This video will review how to find the equation of a line using the point-slope form of a line. First, let's review the basics of slope. We know that the slope of a line is the change in the y-coordinates divided by the change in the x-coordinates, and the popular slope formula is this. But what we also know is that the slope of the line stays the same no matter which points you use. And since it doesn't matter which points I use, in some sense you can think of, you can choose any point you want for this one. You can let that second point vary, keeping the first point the same, and you're going to get the same answer for the slope. So since this first point, or I guess x2, y2 could be anything, we could rewrite this with variables in here for x and y. And that's going to be important in helping us get the point-slope form of a line. So we have that the slope is any point y minus a specific point y1 divided by any point, the x-coordinate of that same point, minus the x-coordinate from point 1. And you'll notice if you take this fraction here and you multiply it by x minus x1 on both sides, then on the right side the x minus x1 will cancel, and if I switch the order of multiplication here, I have m times x minus x1 equals y minus y1. And then if I switch the side that the x's and y's are on and rewrite it, I get this. And this is what's known as the point-slope form of a line. And the components of it are the slope right here, is this number outside of the parentheses, and this point with this y1 and this x1, that is any point on a line. So that's what we're going to use to find the equation of a line. So this one says use the graph given to find the equation of each line. I've got a black line and a blue line, and I'm going to do the black line first. In order to use point slope, I need to remember point slope is y minus y1 equals m times x minus x1. This y1 and this x1 comes from any point on the line, and I actually have a couple of them. The key thing I need to do is figure out what m is. So for this particular point, I've got 5, 3, and 2, 1. So m is going to be 3 minus 1, that's the change in the y values, divided by 5 minus 2, that's the change in the x values, so that's 2/3. Now I can take that as well as any point, and I can choose either one of these points to be x1, y1. For the sake of discussion, I'll just make the first one, 2, 1, be that point. So for this black line, my equation is going to be y minus, I'm putting y1 in that spot, so it's y minus 1. My slope is 2/3, and then I need to put the x coordinate in of this point in the second spot in the parentheses, so that's times x minus 2. So this is the point-slope form of the line. It's also very common once you have that to distribute and isolate your y. So if I do that, I'm going to have y minus 1 is 2/3 x minus 4/3. And then if I add 1 to both sides, I get y equals 2/3 x minus 1/3. You'll have to find a common denominator there. Okay, now for the blue line, same thing. I've got these points, 2, 6, and 4, 0. So the first thing I want to do is find the slope. So for the blue line, I'll call this one x1, y1, and 4, 0 will be x2, y2. So I'll have 0 minus 6 in the numerator and 4 minus 2 in the denominator. So that's negative 6 over 2, or negative 3. So that's my slope. And then if I go to the point-slope form, y minus y1 is m times x minus x1, and I'll just use this point here as x1, y1. I have y minus 6 equals, my slope is negative 3, and then x minus the x-coordinate at this point is 2. So that's the point slope form, and if I want to solve it for y, I'll get y minus 6 equals negative 3x plus 6. And then if I add 6 to both sides, I get y equals negative 3x plus 12. Okay, here's a couple where I don't have the graph. Find the equation of the line passing through negative 2, negative 3, and 1, 3. First thing I want to do is find the slope. It's going to be 3 minus negative 3 over 1 minus negative 2. That's 6 divided by 3, which is 2. And then I can choose either of these points to be x1, y1. I'm going to choose this one because I like working with positive numbers better. So I have y minus y1 is m times x minus x1. I fill in numbers for these pieces here that I'm putting a box around. So my equation is going to be y minus 3 equals, my slope is 2 times x minus 1. And again, the 3 and the 1 come from that point there. And then like in the other problems, if you want to isolate your y after the fact, you can. That means y equals 2x plus 1. So that's the point slope form of a line. This one right here is point slope, and after we solve it for y, that's slope intercept. Couple more. Slope in this one, negative 1 minus 5 over 6 minus negative 2. That looks like negative 6 over positive 8. That's a fraction, but that's okay. That's negative 3/4. And I can pick either one of these to be my x1 and my y1. I think I'll pick this one. When I do that, I get y minus negative 1 is negative 3/4 times x minus 6, which simplifies to y plus 1 equals negative 3/4 times x minus 6. That is the point slope form. If you want to solve it for y, distribute the negative 3/4 and move that one over, you can get the slope intercept form.